Hello everyone, this is our third video lecture on unit testing. In our first video, we discussed the general philosophy of code testing. Especially, we need a ground truth to test any piece of information, whether it comes from a person saying something or a function returning some value. Our goal is to verify that the returned value matches our expectation for that function. In our second video, we showed the mechanics of unit testing. We used IntelliJ. We walked through a step-by-step process to test a simple toy function in Java. In this current video, we'll continue to explore the mechanics of unit testing. Especially, we will discuss parameterized test and value sources. We also explore how to load our test data from a file. Okay, so quick recap. I have a class named libclass, which will contain essential library functions. Currently, it contains only one library function, isPrime. This function has clearly some issues, which we have been trying to detect using our unit test instrument. I cleaned up the code a little bit, especially the documentation. I added imports so that our annotation &test looks cleaner. My plan is to share the source code with you on GitHub, but not today or tomorrow. I want you to experience the entire process first. This is our first use case, slightly renamed. Here the data point is 3, a single data point, for which we know the ground truth, which is true. Since our function by design returns true, our first test with a single data point will be successful. So let's try that. Yeah, it is green, it's successful. This is part of our video lecture 2. Then we realize maybe we need to add more data points. Instead of 1, what if we add 2 data points? Here we are trying data point 3 and 4. Again, the function returns true. So for data point 4, which is not a prime, means the ground truth is false, our test case will fail. Yeah, and it says fail. It was expecting false, but the function returns true here. So it's more, I would say, more robust test case. Then the third test case, which was part of your in-class activity, the key idea is to use a series of data, like an array or a list of random inputs along with their ground truth. Random inputs, their ground truth. We get the output from the function and then compare our output and ground truth using a mechanics called assert array equals. Let's run it. Yeah, it says expected false but was true. In general, the test failed, which is good. So we learned that we need to test with multiple data points. But there are some issues with this approach. Number 1, we have to write some unnecessary code here. Like here, we need to declare our output array, iterate over, and populate our output array. These are unnecessary overhead. We don't want to do that. And then the second problem is we need to hard code all of our input and the ground truth within source code, which is generally not a good programming practice. So to overcome these 2 limitations, we will be trying a new approach today, which is called parameterized test. Okay. I'll explain the mechanics of parameterized test in great detail. First, we need a new kind of annotation, which is at parameterized test. Let's compare this new annotation with our previous annotations. Okay, so at test was our previous annotation. Now we need parameterized test. The second difference between our parameterized test and non-parameterized test is we need another annotation, &value sources. This value source is the parameter in parameterized test. Value source has two parts. Int, it indicates what type of values we are parameterized. Int is the plural of int, means we are passing bunch of integers. And that bunch of integers are on the right. Okay. Another difference between our new test function all primes and the previous test function is prime multiple data point array is that our new test function is taking a parameter. So you may ask, who is calling this function and who will be responsible to pass the parameter? Yeah, this is the interesting part, because parameterized test will internally call all primes, our all primes function one by one with values from value source annotation. So it will call all prime with value 2, number would be 2, then this number would be 3, 5, 11, 19. So let me run it first. Okay, so you can clearly see from the left hand side, all primes is taking values from our value source one by one. There are a few more things we need to consider here. Since we are passing only one parameter, and no ground truth, we need to strategize what values we should provide. Let me compare our current parameters with the previous method. We have our input values, random integers, and the ground truth, but there is no ground truth in our value source. So what should we do? My strategy is to include numbers that I know are prime. For example, out of 2, 3, 5, 11, 19, 20, 28, I know these are primes. 2, 3, 5, 11, 19 are primes. So I put only primes as my parameters. Since I know these are prime, meaning the ground truth is true, I can use assert equals, and the ground truth is true for all of my parameters. Lib plus is prime number. So I hope it is not too confusing. I know the ground truth for all of my parameters. I would like to use assert equal. And for all of these numbers, I know the ground truth is true, so one assert equal will work for all my parameters. Okay. Same thing, I can write another function, not all primes. And here I put numbers that are not prime for sure. Here 20, 28, 20, 28. Since these are not prime, my ground truth is false. I can use false as the first parameter in assert equal, and the second parameter is coming from whatever this function will tell. Okay, let me run this function. Okay, so 20 failed because by design function says true. 28 failed. At this point, I hope you can see the pros and cons of different approaches. There is no free lunch. We can either do everything manually like before, like here, or we can think through what parameters we should provide in parameterized test. In general, parameterized test is great, but what if we need to pass multiple parameters? Like here. Well, earlier I mentioned JUnit framework is industry standard, meaning there exists some mechanism to pass multiple parameters. This mechanism is based on the concept of CSV, comma separated values. Okay, so this is my test case that use CSV format. The key difference here, we are not using value source annotation. Instead, we are using CSV source annotation. If you're not familiar with CSV file, let me give you a quick intro. Usually a CSV format or CSV file ends with .csv. Each line indicates a data record. So how many data record we have here? Line 1, 2, 3, 4, 5. So we have 5 records. Each line must follow the same format. For example, 2 entities separated by comma. I cannot put 3 here because that will break the integrity of my file. It will tell I got a record at line number 2 that contains three parameters, whereas all other records contain 2 parameters. So I cannot do that. Okay. In general, values are separated by comma, but many people prefer semicolon or something else. But we can use comma, the default one. Now, let's take a look at the mechanics of CSV source. Here, under parameter, I copied each line here. 3, true, 3, true. You probably guess what 3 is. 3 is my random number. True is the ground truth. Similarly, 4, false, 5, true, 6, false. 6, false, yeah. Each line, I put them under string. Literal means the quotation. The comma here is very similar to the comma in other value formats, which is just a separation of entities. Next, take a look at the function signature. Since I put 2 parameters in my CSV data, I need the same 2 parameters in my function signature. Okay, then I know the first value would be integer, so I use integer. Input, it doesn't matter, you can use something else, param1, param2, that is okay. But the type is important. I know the first one is integer, so int, and the second one would be a boolean, so bool or boolean. With that format, parameterized test will look up the value, look up the string value. It will parse based on the location of comma. So the first part would be 3, the second part would be true. Both of them are string. It will internally convert 3 into an int and bind it with input. Similarly, it will convert string true to boolean true and bind it with my parameter gt. Once it is done, I have access to my input and gt. I can use assert equals gt and the function and pass that input to function and compare. Let me run this code. Okay, so it says 3 true, that passed by chance. 4 false, expected false, actual true. 5 true, anything that is true, our test will pass because of the function design. Similarly, 6 false. Okay, I don't know what you think, but parameterized test with CSV source is by far the best method. It is clean compared to our array equals method. Look how many lines we have to write. Compared to value source method, we don't have to think through our parameters or the ground truth should be true or false all the time. No, we don't have to think about them. We have ground truth input, just like our single data point assert equal is very similar to assert equal. The only negative side, I would say, is the syntactic sugar. We have to put that string literal around my data point and then the comma separation. I don't think it is too bad. The bad thing, though, is we have to put our data within our source code, which is generally a bad practice. So how do we fix it? Okay, so the last part is about separating our data from source code. Let me quickly explain the mechanics. We are not using CSV source anymore. We are using CSV file source. And our data will be loaded from a file under a source. The name of the file is data._test.csv file. Okay. How do you create the CSV file? Quick question. Answer, it is pretty straightforward. If you expand our project tree on the left, under main, we know we have Java that has our actual class. We also know the test folder that contains our test class, but we haven't explored our resources folder. This is the time to explore it. The first thing I usually do, right click, open in Finder. There you go, open in Finder. I want to make sure resource is within my current project, so I'm going up. Yes, it is main. And yeah, this is my hello test. Source, main, Java, and the resource. Okay, so resource is actually part of my project. I don't need that anymore. Okay, then you can right click, create a new file. I already have a file, data_test, but for demonstration purpose, let's name it data.csv. It's important, comma, separated value. We want our file to be CSV. Okay, so this is the data.csv file. The way I can populate this file is quite straightforward. I usually add a meaningful header like param1, param2, gt, ground truth, and then I add param1 like 2, 3, true. Enter for creating new record. It could be 7, 3, 8, false. You can also add a space right before your data for readability. It doesn't matter, Command S. We can open our CSV files in any standard word processor. For example, I can open it with numbers. Yep, it looks good. Excel. Yeah, so the format is correct. It can show me 2 columns. The separation are perfectly aligned. I should not do anything, not save as, because Excel may change the format. So I'll take a quick look. Looks like everything is okay, and I close it. Do not save. Okay. All right. Okay, coming back to our test case. Parameterized test, it is now default. We don't have to, we know what this one is. File location, I would say keep your file under resource at the root level. Do not create any kind of hidden folder. What if I create a folder? I could. So when the project gets bigger, we may need to create folder structure. Let's say I can name it as images. I can create another folder, sounds, and then data. I can move data to my data folder for better organization. Okay, so yeah, in this case, my CSV file is not under root. It is under root. Root means resource, data underscore slash data. Okay. All right. I'm ready to run this. There you go. It is working fine. Okay. This is the ultimate method, because see how powerful this one is. I can test 100. I know 100 is not prime, false. New 119, true. Save, run it again. Perfect. So a clear separation from data from data to source code. I hope you are following along. For your in-class activity, I wrote it down here. Let me put it back. Command / okay. You need to write a function, get some or anything. The quality of this function should be A. It should take at least 2 parameters. Could take 3, 4, doesn't matter, but it should at least take 2 parameters, more than 1. And this function would be super incorrect. For example, this function should perform the summation of parameter 1 and parameter 2, but now it is returning only 1. So it's a wrong function. Don't even worry about the correctness. Once you are done, you have 2 tasks. Task 1 is to write a parameterized test using CSV source. A hint, your CSV value may need 3 parameters. First one is param1, param2, and the GT, ground truth. And then task 2, try to put this information on a CSV file, data test, data.csv, doesn't matter, and do the same testing like here. All right, that's it. I'll see you on Friday.